Welcome all to another topic of gravitation, and which basically will discuss about gravitational lines of forces. So gravitational lines of forces are just a hypothetical lines which is used to giving an idea about the strength as well as direction of gravitational field. So we already discussed about gravitational field. So if you want to get a visualization of that or an idea about this gravitational field, its strength as well as direction, then we'll use this gravitational lines of forces. So basically these are hypothetical lines, means imaginary lines in gravitational field, which gives information about the direction as well as magnitude of gravitational field strength at that particular point. So let's see how we'll represent its magnitude as well as direction by using this gravitational field lines. So if you're considering that at a particular point gravitational field lines are, let's say, something like this. So if you'd like to find out the direction of gravitational field at a point, let's say somewhere over here, so just draw a tangent at this particular point that is going to give the direction of gravitational field at this point. So if you want to find out the value of gravitational field at this point, so this is the direction of gravitational field at that point. If you want to find out a point over here, so this is the direction of gravitational field at that point. So if you want to find out the value of gravitational field at any point, just observe the direction of gravitational field lines, and tangent at any point is going to give the direction. Now if you would like to know about or getting an idea about this gravitational field strength, so let's say if you want to compare the gravitational field strength at point A as well as another point taken as point B, so we can take a similar area or volume over here. So then we'll find out what about the number of gravitational field lines which is passing through this region and this region. So you can observe that density of number of gravitational field lines are more at point A. So this field density is going to give an idea about its gravitational field strength. As you can observe that number of gravitational field lines on this region is more as compared to the same area that we are selecting over here. So you can write strength of gravitational field at point A is greater than strength of gravitational field at point B. And tangent at any point is going to give the idea about its direction. So remember these basic things like these are hypothetical lines in gravitational field which gives information about the direction as well as magnitude of gravitational field strength at a point in the region. And in a region, these lines are drawn such that tangent to any point on a line gives the direction of gravitational field at that point, and density of lines, number of lines per unit volume, will give an idea about the magnitude of gravitational field strength. Now we can just observe some examples how this gravitational field lines look like. Like if you are considering a solid sphere over here, so the direction of gravitational field lines will be like this. All these gravitational field lines are like towards the center of this mass, or if it is a sphere, the gravitational field lines will be something like this. So if you want to find out the direction, so we can just, if you want to find out the direction of gravitational field over here, so we can just draw a line in such a way that it is always going to attract this one. So this is the direction of gravitational field. And for some other objects also we can just observe. Suppose if you want to observe it in a three-dimensional space, then it will be something like this. From each and every possible direction, this gravitational field lines are moving towards this mass or towards the center of mass of this particular object. So this is the direction of gravitational field. Now if you are considering a two mass system, then we can observe how we'll draw the direction of gravitational field over here. So let's say if you are just considering two masses m1 and m2, the direction of gravitational field will be something like this. That means if you are taking a small any point over here, so this mass m1 is going to attract this one, and this m2 is also going to attract this one. So it depends upon the magnitude of this m1 and m2. What about the direction of net force? That will be the direction of gravitational field at that particular point. So this is the way we'll represent gravitational field lines. And if you want to put direction, so this is always attractive in nature, so direction of gravitational field lines will be something like this. Same as like that, let's say if you want to observe the direction of gravitational field between Earth and Moon, so you can consider the situation something like this. So these gravitational field lines are moving towards the Earth, because if you are just considering a point over here, then Earth is going to attract with some gravitational field, and this Moon is also going to attract with the exert some gravitational field. But we know that the strength of gravitational field due to Earth is more, so resultant may be along this direction. So there is a direction of gravitational field over here, and this point represents a neutral point. Just now we discussed about that null point also. So this is the null point where the value of net gravitational field due to moon and earth is cancelled, or net gravitational field over there is equal to 0. This is the way we are representing this gravitational field lines. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please contact. Thank you.